So the experiment today is all about chemical reactions, and in chemistry this really is at the heart of what we're going to be discussing, right? So as a quick reminder, chemical reactions involve chemical changes, and those are changes that involve a change in the identity of a substance, right? So through a chemical change you end up making brand new substances that are different than what you started with. These chemical changes can be represented using chemical equations. There are several things that you're going to be looking for in the experiment today that are going to be clues that tell you, or that may indicate, a chemical change has occurred. You may see all of these, you may see just a couple of them. So if you make a solid, if you end up producing a solid, which we call a precipitate, when you mix two aqueous solutions together, that indicates a chemical change. If you see the production of a gas, which will be represented by bubbles, maybe big bubbles or small bubbles, but that tells you a gas is being produced. You may see color changes, and then you may also be able to measure temperature changes that are indicative of whether heat is being absorbed or released by the reaction. So there are several things that we can look for, and you will see these in the reaction test tubes today. In our first reaction tube, we're going to add together 2 milliliters of sodium sulfate. So that's going to go in first. And to that, we're going to add 2 milliliters of lead 2 nitrate. And as a reminder, whenever you mix two things together in a test tube or any other container, it's a good idea to agitate or to flick the tube to make sure that everything is mixed properly. Okay, so upon adding our lead 2 nitrate to the sodium sulfate, we can make some observations. And this is in test tube 1. In test tube 2, we've put in 2 milliliters of hydrochloric acid, and we've stuck a thermometer in here to monitor the temperature. So right now, just the hydrochloric acid on its own is sitting at just over 25 degrees Celsius. So we're going to add to this in test tube 2. We're going to add some sodium hydroxide, and we're going to make some observations in terms of what we see, but also in terms of any temperature changes. So we're going to add our sodium hydroxide to this. We're going to give it a swirl to make sure it's mixed properly. And then if I look at my thermometer, okay, you can see that the temperature has changed from what it was originally. Originally it was just over 25 degrees Celsius. So that's test tube 2. In test tube 3, we already have in here some silver nitrate solution. And into that solution, what we're going to do is we're going to place one of these copper strips in there. So here's our copper strip, and we're just going to place it directly into our silver nitrate solution. And we're going to monitor this over the next couple minutes. So we give it a quick swirl and let it sit. We'll check on it periodically. So this is after about 3 minutes of the solution sitting in here. or the copper sitting in the silver nitrate solution. This is after about 5 minutes. It's maybe a little difficult to see. So we placed a white background. You'll notice that the solution has gradually become a light blue color. And then if I take this and I agitate it a little bit, you can see some solid material being formed. It looks like a grayish white solid being produced as well. In test tube 4, we're going to place 2 milliliters of potassium sulfate. And to that, we're going to add 2 milliliters of sodium nitrate. We're going to swirl to mix. And make any observations. Into test tube 5, we're going to place 2 milliliters of iron III chloride, which in contrast to all the other solutions so far, this has a yellowish color associated with it. And to that, we're going to add 2 milliliters of ammonium hydroxide. Swirl to mix. And that is in test tube number 5. In test tube number 6, we already have in there 2 milliliters of sulfuric acid, and we have a thermometer in there. And the temperature is starting off at just over 25 degrees Celsius. And to this, we're going to add 2 milliliters of the ammonium hydroxide solution. We're going to swirl that up to mix. And we can monitor the temperature again. Temperature is now 33, just over 33 degrees Celsius. And if I touch the test tube, it feels a little warm. And that's in test tube number 6. In test tube number 7, we already have in there some sulfuric acid, some H2SO4, and to that we're going to add a piece of zinc metal. So there's our zinc. And all we're going to do is just place it in our test tube with sulfuric acid and make some observations. Give it a quick swirl. And what may be difficult to see in the video is that there are lots and lots and lots of tiny bubbles that are being produced as the zinc actually breaks down. Right, so lots and lots of bubbles that tells you some sort of a gas is being produced in that reaction in test tube 7. So this again is test tube number 7 with the zinc and the sulfuric acid. If you look closely, you may be able to see those bubbles are becoming a little bit bigger now and they're rising to the top. Right, so those bubbles tell you that a gas is being produced. And in test tube 8, we're going to mix together some sodium chloride solution. And to that, we're going to add some potassium nitrate. All right, so we give it a quick swirl, make sure everything's mixed well. Flicking the tube is another strategy to make sure the contents are uniformly mixed. And that's in test tube number 8. Okay, so in this first reaction, what we are going to do is to take a strip of this magnesium ribbon and we're going to place it in that flame and make some observations as to what happens to it. And then also we will observe the product that we end up making at the end. So in order to illustrate this more clearly, we turn the lights off and we're going to take our magnesium ribbon and place it in the flame. So to give you a comparison of what we started with and what we ended with, this is the magnesium ribbon that we started with, and after heating it over the Bunsen burner flame, this is our product.